Hey guys, today I'm going to teach you how to solve one and two-step inequalities. By the end of this lesson, you'll be able to extend your previous understanding of solving equations and transfer that understanding into solving one and two-step inequalities. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. So like I said, for today's lesson, we're going to cover how to solve one and two-step inequalities. But before we do that, I want to review solving equations because it's the exact same process. So when we solve equations, we always start by drawing a line on the equals and separating our equation into a left and a right because this side is going to be the same as this side. We want to separate that with a line on the equals. We also want to make sure that we're remembering that we want to get the variable by itself. The variable is the letter that represents a missing or unknown number. So we're trying to figure out what x equals. So our goal is going to be to use inverse operations to get the x all by itself. And inverse operations just means do the opposite. Go in reverse PEMDAS. So what I'm going to do is off to the side here, I'm just going to write PEMDAS, parentheses, exponent, multiply or divide, add or subtract. When we solve an equation, we are doing the opposite of what's being done to x. So if the first thing we would do is multiply by 2 and then add 1, we want to actually go in reverse. We want to start by looking at adding and subtracting and do the inverse operation. So we need to get rid of a plus 1 first because we're going to get rid of the adding first. The opposite of plus 1 is minus 1. If we do it to one side of the equation, we have to do it to the other side. So on this line, we will write minus 1 on the right. Whatever you do to the left, you have to do to the right. And we take a minus 1 because we need to do the opposite of a plus 1. The next step is just going to be to simplify. 1 minus 1 is 0. 11 minus 1 is 10. On the left side of my equation, it's still the 2x, so I just bring it down. So I'm done with my adding and subtracting, and now I'm going to look up and see if there's any multiplication or division. This is a times 2 because it's right next to the letter. A letter and a number right next to each other means multiply. So I need to do the opposite of a times 2. The opposite of times is divide, and I'm just going to divide by that number 2. So if I do it to the left, I have to do it to the right. 2 divided by 2 is 1. So there's only one x left on the left, and 10 divided by 2 simplifies to 5. So my answer is x equals 5. That's it. I'm done. That's my final answer. However, I always like to check to make sure that if x equals 5 here, that in my original equation, if I put in a 5 for the x here, then I should end up with 11. So 2 times 5 is 10 plus 1 equals 11. If that works and that's true, then I did my equation correctly, and I know that I got my answer x equals 5. Like I said, inequalities can be solved just like an equation, but with a few exceptions. There's just one extra thing we need to remember. So let's just review here when we're looking at one-step inequalities. The goal when solving an inequality is to isolate the variable like we just saw with an equation. We use inverse operations to do so. And whether it's an equation or an inequality, whatever you do to one side, you have to do to the other. The inequality must remain balanced. So that's not new. That's just like an equation. The only new thing is this number 3 here. So this is really important. Please pay attention. When you multiply or divide by a negative number in an inequality, the inequality sign is flipped. So I'll show you what that looks like in just a minute, but that's just one special rule with inequalities you just have to put in your brain to remember. When you multiply or divide by a negative in an inequality, the inequality sign is flipped. So let's just start with number 1 here. We're not going to use that rule for number 1 because there's no negatives. You have n plus 5 is less than or equal to 16. I always like to start by drawing my line on the symbol, whether it's an equal sign or an inequality symbol. I want to get the n by itself. I can't graph this or solve it until the n is isolated or by itself. So I'm going to use inverse operations to do so. The opposite of a plus 5 is a minus 5. If I do it to one side, I have to do it to the other side. It has to be balanced. So 5 minus 5 is 0. It's gone. So the only thing left on the left side of my equation or inequality is an n. On the right side, I see 16 take away 5. 16 minus 5 is 11. And instead of writing an equal sign here like we used to do, I'm going to use the inequality symbol that's given. It's a less than or equal to sign. This is my final answer. I know I'm done because the only thing on the left side is a variable, and the only thing on the right is a number. N is less than or equal to 11. Now that I have the inequality solved, I can graph. So I want to go ahead and I've given this little chunk of a graph here. I'm just going to go ahead and use some of the numbers that are around 11. So I'll put 11 here in the middle, and I'll just put a 10 on one side and on the other, 12, 13. So I just picked numbers because I put 11 here in the middle. Doesn't matter where you put it. just numbers that are around it. And I know that n is any number that is less than or equal to 11. So if I see an equal to sign, I know I'm going to have a closed circle. So on the 11, I'm going to put a closed circle here, and I'm going to shade any number that is less than 11. That's going to be 9 and 10. That's going to be the direction of the 9 and the 10. And I want to shade with an arrow because it's any number that is less than or equal to 11. So you're probably wondering now, how do I check this? How can I check to see if I'm correct in solving my inequality and graphing it? Here's how you check. You just pick a number that's shaded on this side of the line. You can pick a 10, you can pick a 9, and you want to plug that in for the n. When you plug this in, you can plug it into the original equation, n plus 5 is less than or equal to 16, or you can plug it in here. I would go ahead and do both just to make sure you did this right. If you put in a 9 for the n, that should work. So if I put in 9 plus 5 is less than or equal to 16, I end up with 14 is less than or equal to 16. That's true. 14 is less than 16, so I know I solved this correctly. You also want to plug it into this one. That 9 or that 10, either one, 10 or 9 is less than or equal to 11, so you know you did that correctly. That's how you check. You just pick a number that's shaded and you plug it in to double check that you're correct. So go ahead, what I want you to do is try number 2 by yourself. Solve this one-step inequality just like I did over here on number 1. And whenever you're ready, press play on the video to check. Okay, so hopefully you just tried that by yourself. If you want to go ahead and fast forward a little bit and check your answer when it's all solved, you can do that. Otherwise, I'm going to go ahead and walk through this with you. The first step I want to do when I'm solving an inequality is I want to draw a line on the inequality symbol. Whether it's an equals or an inequality symbol, I want to draw my line to separate it. The inequality must remain balanced. Then I'm going to use inverse operations or the opposite operation to get the c by itself. I know I'm not done until I have just a c, just the symbol, and then just a number. So I'm going to do the opposite of a minus 8. The opposite of minus 8 is plus 8. If I do it to one side, I have to do it to the other side. So a negative 8 and a plus 8 cancels. The inverse operation cancels out. And all I'm left with on the left is c. On the right, I have 14 plus 8. I can actually do 14 plus 8. 14 plus 8 is 22. And then in the middle here, instead of putting an equal sign, I'm going to keep that same inequality symbol, which is a greater than sign. So c is greater than 22 is my final answer. I can graph this. Remember, I'm just going to choose some numbers that are around 22 here. I'll put 22 in the middle. It can be a rough sketch here. And then I'm just going to go ahead and graph this. It's an open circle because it's an inequality symbol that does not have an equal sign. So it's around 22, but not exactly. So I don't fill it in. But I do want to shade in the direction of numbers that are greater than 22. The numbers that are greater than 22 are 23, 24, and so on. So I shade this way. I can check this 2 ways. I can plug in one of these shaded numbers into the original equation and into this equation. So I'm going to go ahead, or inequality, not an equation, sorry. I'm going to go ahead and pick 23, and I'm going to plug it into the first one. So 23 minus 8 should be greater than 24. 23 minus 8 is 15, and 15 is greater than 14. So since this is correct, I've solved my inequality correctly, and it's graphed correctly. So I know that I'm right. So now using these two as examples, I want you to go ahead and try number 3 and number 4. The only difference between 3 and 4 from the first two is that the operations here are multiplication and division. So when you do the inverse operation of multiplication, remember, you're doing division. When you do the opposite of division, you do multiplication. So go ahead and try both of these by yourself, and when you press play, I'll have both of the answers already solved for you to check. So pause now, try these by yourself, and press play when you're ready to check. All right, so here's how I worked out these problems. I ended up with g is less than 4 because I divided by 12 on both sides, and then I plugged in a 3 to check. You can plug in any number that's less than 4. On number 4 here, I realized that it was divide by 3, so the opposite of divide by 3 is multiply by 3. So I ended up with p is greater than 27. I used a 30 to check because 30 divided by 3 I know is 10. I know 10 is greater than 9, so I know I did this correctly. So your final answer to solving these inequalities is going to be the answer g is less than 4 and p is greater than 27. That's your final answer. This part where you check is just to make sure you did it correctly. And that's going to be really important later on whenever we see those negatives and you are reminded of rule number 3 here, because otherwise we have not had to use rule number 3. So hopefully you got at least one of these correct. If you did, give yourself a pat on the back, and let's move on to some of these where you are going to use rule number 3 here, where you're going to start seeing negatives. So like I said, inequalities can sometimes involve negative numbers. Remember, when multiplying or dividing by a negative number, please make sure that you flip or switch the direction of the sign. For your first example, I'll show you what I mean. Let's look at number 5 together. So just watch me do this, and then you can try the next one on your own. Just like in the past, my very first step when I look at this inequality is going to be to draw my line on the equals or the inequality symbol. I do that because this side on the left has to be balanced with this side on the right. Then I want to look at what operation is being done here. It's a -4 right next to a k. If it's a letter next to a number, that means multiply. So I need to do the opposite of times. That's going to be divide. And I always want to do the division by the number that's being multiplied. So the opposite of times -4 is divide by -4. If I do it to one side of the line, I have to do it to the other side of the line. So I'm going to divide by -4 on both sides. -4 divided by -4 is just k. So k is all alone on the left. And I know that 22 divided by -4 is going to be a negative number, and it comes out to be 5.5 or 5.5. Now here's the part whenever you need to remember the rule. Whenever you multiply or divide by a negative number, which we did, we divided by -4, you have to flip the direction of the sign. So instead of it facing this way, I'm just going to flip it around. Now it's going to be facing this way. And that's it. I'm done. Just like normal, I solved my equation by using inverse operations. I solved the inequality the same way. The only difference is whenever you multiply or divide by a negative number, you should have alarm bells go off in your head, and you should realize, okay, if I multiply or divide by a negative, the rule is to flip the direction of the sign. So let's look at this on a graph, and then we'll check it, and hopefully when we check it, this flipping rule will make more sense to you. So let's start by graphing the -5.5. That's going to be between the -5 and the -6. So I'm going to just put a closed circle there because it's got that inequality symbol with an equal sign. I'm going to shade all numbers that are greater than that. So when we think about numbers that are bigger or greater, we want to think about numbers that are to the right of that. Remember, it's better to owe me $2 than it is to owe me $5.50. And then hopefully the part where I flipped the inequality symbol makes sense with checking it. So a number I can use to check would be a -2 because it's shaded. So I'm just going to pick -2. You can pick any number that's shaded. When I plug it back into my original inequality, I end up with -4 times -2, which is a +8, is less than 22. That works. So I know I'm right. But let's plug it into the second one. -2, using that same number, needs to be greater than or equal to -5.5. That is true, and we know that that's true because we just saw it on the number line. If I didn't change the direction of my inequality symbol and I kept it like it was, it would say this, and that wouldn't be true. -2 is not less than -5.5. It's greater than because it's closer to 0. So we have to flip the direction of the inequality symbol when we multiply or divide by a negative to keep our inequality true. Let me go ahead and show you number 6. I hope that's not confusing to you. I understand that it might be. That's kind of confusing to me still. So I'm going to do it number 6 for you. If you want to try it by yourself, you're more than welcome to. But I'm going to start by doing like I do any inequality that needs to be solved or equation that needs to be solved. I'm going to draw a line on the symbol. I need to get rid of a divide by -2 because I want the s all by itself. So the opposite of divide by -2 is going to be to multiply by -2. I'm going to use a dot for the symbol for multiply. So you can do multiply with a times, a dot, a parentheses, whatever, as long as you're multiplying by -2 on both sides. So I'm left with s, and I've got a 5 times -2, which is -10. Now remember, you have to flip the direction of the sign whenever you multiply or divide by a negative number. So instead of the inequality symbol that's greater than, I'm going to make it a less than. The alligator was eating this, and now it's eating this. It has to flip the direction. Now I've got a single variable, and it's set less than to a -10. I can graph that. It's a less than symbol without an equal sign, so I'm going to use an open circle on the -10. So it's around -10, but not exactly -10. And it's all numbers that are less than that. So I'm going to shade this way. One little hint that you might have noticed is that whenever you have it set, when you start with the variable, like the variable is on the left, you're going to shade the direction that it's pointing. So like here, it's a variable is greater than or equal to -5.5. The arrow is pointing to the right, so I'm going to shade to the right. Because the variable is what we start with, I can shade in the direction that it's pointing. So that's one little hint that you can use. As long as you have the variable that you're starting with and you start by saying the variable, you're going to shade that direction. Okay, so I want to go ahead and check this. I'm going to use the original equation to check it, and I'm going to plug in a negative 20. I know a negative 20 is going to be in this direction. And I know that it's divisible by negative 2, so it's easier to check. So I'm going to do negative 20 divided by negative 2, and that should be greater than 5. Remember, I'm plugging it into the original equation. Negative 20 divided by negative 2 is a positive 10, and 10 is greater than 5. I want to check the other equation just to show you here. If I put in a negative 20 in for s in the simplified equation, where it's just that s is less than negative 10, this is right. If I didn't flip the direction of the sign, it wouldn't be true anymore. So I'm correct. I know that I'm right because I can plug it into both equations or inequalities, and it works. So hopefully I didn't lose you too much, but just so you know, this is the exact same process as solving a regular equation with one extra rule. All we did today was learn one extra rule. You start by isolating the variable using the inverse operations. Then you have to balance your equation by doing the same thing to both sides. And then we know how to graph. The only thing that's different now is that if you multiply or divide by a negative, you flip the direction of the sign. So I want to move on and really quickly cover solving two-step inequalities because it's the exact same thing as solving two-step equations. The only difference is that you have an inequality symbol instead of an equal sign, and that extra rule where you have to flip the direction of the sign if you multiply or divide by a negative. So it's the same rules, you're just undoing your operations. So you'll notice that the steps are the exact same as you've done before, and if you follow these steps, you can't mess this up. The first step is going to be to undo addition or subtraction with the inverse operation. So start with adding and subtracting. Then you want to undo multiplication or division with the inverse operation. You're going in reverse PEMDAS. The third step is going to be just to remember when you multiply or divide by a negative number, the inequality sign is flipped. Just keep in mind your ultimate goal when you solve an equation or an inequality is to isolate the variable. You want to get the letter all by itself. And then you want to check using the inequality sign, which just means, is it pointing the right way? Did I use an open circle or a closed circle when I graphed it? And when you've done these steps, you can't mess this up. So I'm going to go over these two examples real quick for you, and then you can have the rest of these to try and practice. So if you want to try these by yourself, you're more than welcome to, but I'm going to go ahead and go now, starting with this one, 5x plus 9 is less than 17. I'm going to solve this inequality. I'm going to solve it by drawing a line on the inequality symbol, and I want to go in reverse PEMDAS. I want to start with addition or subtraction first. I see a plus 9, so I'm going to do the opposite of plus 9. That's minus 9. And if I do it to one side, I have to do it to the other side. So I'm left with a 5x on the left. I keep my inequality symbol. And 17 minus 9 is 8. So 5 times a number is less than 8. I want to go ahead and do the opposite of times 5. So I'm going to divide by 5. 5 divided by 5 is 1. So I'm left with 1x is less than 8 divided by 5, which is 1.6. X is less than 1.6. So what I want to do is pick a number that's less than 1.6. Let's just say 1 and plug it into my original equation. So x is any number that's less than 1.6. So it doesn't matter what you pick. I picked 1 because it was easy. So 1 times 5 is 5. 5 plus 9 is 16. 14. Either way, it's less than 17. Let's look at this one on the right here. It's another two-step equation or inequality. Excuse me. I want to start by drawing a line on the inequality symbol. And I want to do the inverse operation of subtraction first. I'm going to undo the subtraction with addition. So instead of a minus 3, I'm going to plus 3. 13 plus 3 I can do. That ends up being 16. And I keep my symbol in the middle. Negative 2x is left. I want to get rid of a times negative 2 now. So the opposite of times negative 2 is going to be divided by negative 2. This is where you should see like lights flashing in your brain. I just divided by a negative. If you divide by a negative, you flip the direction of the sign. So instead of it pointing to the right, it's now going to point to the left. 16 divided by negative 2 is a negative 8. So that's it. Solving inequalities is the exact same as solving equations with only one extra rule about flipping the sign if you multiply or divide by a negative. So just watch out for those. And then you can always graph these. But since these aren't asking you to graph, it's just asking you to solve. That's all you have to do. So here are some practice ones for you to try. If you've done these, send them to me and I'll check your answers. All right, guys, that's it. If you made it to the end of this video, please put in the comments an inequality to match the situation. You ready? Mr. C read at least 3 books this month. So if you made it to the end of this video, comment an inequality that represents Mr. Siski read at least 3 books this month. Today we learned about how to solve 1 and 2-step inequalities. It's nice to be able to extend your understanding of solving equations to solving 1 and 2-step inequalities. It's nice to go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.